editing, I was looking at this multiples lesson that Mr. Saul did, and there was no audio file, so I will be talking over Mr. Saul's lesson. So he would be writing what's on the screen, and I will just talk over it. We're looking at multiples today, and multiples is pretty much, and I don't want to overcomplicate it, it's the times tables, simply enough. And if you know your times tables, you know what multiples are. But we'll go into some more significant areas of multiples, such as finding common multiples. Mr. Saul's at the moment writing down all the multiples of 3. So as you can see, all the multiples of 3s are 3, 6, 9, 12, 15, 18, 21, 24. You can go up. Pretty simple to do. These are one of the first things that you learn in primary school. And it's just showing us that if you're finding a multiple of a number, you'd maybe get a question saying, is 9 a multiple of 3? Well, if you're going in multiples of 3, 3, 6, 9, yes, 9 would be a multiple of 3. Here he is looking at multiples of 30. Now, what's happening is that the multiple of 30 is going to go up the exact same way. It's going to have the same pattern as what was presented in the 3 times table. The only difference is that you're going to be adding that 0. Now, it's terrible to say just adding the 0. Why do we add the 0? Well, the place value is increasing by 1, so that 3 is becoming a 30, the 6 is becoming a 60, the 9 is becoming a 90, and the 12 is becoming 120. The place value is the only thing that's increasing. You don't just say add a 0. What Mr. Saul's doing actually is he's giving us a little bit of a strategy here, is that when you're doing multiples of 10, basically, you can just do the normal multiples of 3, and then you can add the 0 after. Only though, if you understand that when you're doing the multiples of 30, you're not just adding a 0, you're understanding that the place value is increasing by 1 place value. Here he's doing the 300 times table, which seems complicated, but it's not. It follows the exact same path. When you're multiplying by hundreds or multiples of hundreds, again, some may say you're adding 2 zeros, but you're increasing the place value by 2 digits. So now we're looking into going to common multiples. So we could look at common multiples of 3 and 4. Now, we've spoken many a time to many children about looking at the word common multiple, or looking at a word that has various different mathematical vocabulary and breaking it down. What does common mean? So what do we have in common? Mr. Saul and I both like math, so that's something that we have in common. And the word multiple, so it's going to be a multiple that both these numbers have in common. Now, the first thing Mr. Saul's doing is he's writing down all of the times tables, or the multiples of 3 and 4. As you can see, on the left hand side he's got the 3, and on the right hand side he has the 4. And what he's going to do is he's going to try and identify which numbers are both multiples of 3 and 4. He's circling 12. Why do you think he's circling 12? Well, if you look at the 3 times table, 3, 6, 9, 12, and 4, 8, 12, that's the first number that both 3 and 4 have in common that is a multiple. So we'll keep going 15, 18, 21, 24. Well, if we could keep going with the 4s, 16, 20, 24. As you can see, both numbers are multiples of both 3 and 4. Are there any more? Well, the 3 times table only goes to 30. So 28, 32, not the case unless you go slightly a bit further, which Mr. Saul has done. He's gone up to 36. And the reason he's done so is because 36 is both a multiple of 3 and 4. And he could go for ages. He could keep going all the way, and he'll find many different common multiples. But sometimes they just might ask you to go up to maybe 40. Make sure you read the instructions carefully, and it will tell you exactly what to do. So the common multiples of 3 and 4 are 12, 24, and 36. What if those numbers were to be 30 or 40? We spoke about multiples that are multiples of 10 of those numbers. So would you be able to do common multiples of 30 and 40? Would you be able to do that? What was the first step that Mr. Saul did? It was that he wrote down all of the multiples of those numbers first, or as many as he could at least, up to a certain amount to make sure. Now he's added here, that is greater than 100. That's clever, because you're not just going to sometimes get a question that would say find the common multiples of 2 numbers. You might get an additional variable to look into and to answer. So the answer's got to be bigger than 100. So Mr. Saul's got to go quite large with these numbers. Well, luckily they're really multiples of 30. That shouldn't be too much of a problem. So he's currently writing the multiples of 30, and he's going to write the multiples of 40. As you can see, he's done his strategy where he's just writing the multiples of 4 down, and then what he's going to do is he's going to multiply them by 10. Now, again, sometimes we say you add the 0, but we don't really like saying that, at least in my school. We say we multiply by 10, we add the place value. So there he goes. He's written them all down. There, he's going to maybe write a line in the middle of the two numbers. The two sets of numbers, shall we say? No. Oh, he's underlined 30 and 40, so that's the first bit done. Absolutely, I agree with you, Mr. Saul. Make sure you've got all the information possible. That's very, very important. Now, I'm sure he's saying that they have to be greater than 100, so I'm sure he's going to get rid of all the criteria that this does not applicable to. So 30, 60, 90, those are not greater than 100, so they're not going to really count, are they? I don't think there is any common multiples of 30 and 40 that are less than 100. But if you look, you see 120 is a clear one. You can see that they are multiples of both 30 and 40. Are they greater than 100? Yes, they are. 240 and 240? Yep. Are they greater than 100? Yes, they are. So he still managed to ensure that he's got the correct answers. I don't think it would change if that criteria wasn't there, but it's just showing you how you could look at an answer and make sure by just writing down the multiples in a vertical line, not horizontal, because you can't really compare them very well. A vertical line is very, very good. So he's written 120, nice and big. I'm sure you're right, 120, 240, unless he'll give some other criteria, I suppose. Maybe the criteria was less than 200. If you had said, find the common multiple of 30 and 40 that was greater than 100 and less than 200, 240 wouldn't be the right answer. So possibly that was something he would have spoken about. We're going to look at common multiples of 20 and 30. That's quite interesting. Yeah, there should be quite a few actually. And he wants them to be greater than 100. And he wants them to be less than, what are we going to do? Less than 180. Okay, cool. So again, the most important thing, write down the multiples. All the multiples of 20 that you can fill up as, obviously don't take too long. You might not finish your test or your work, but write multiples of 20 up to a reasonable amount. I would say up to 180, because you don't want anything more than 180. So I would write my 20 and 30 times tables up to 180. I'm sure that's what he will be doing in a second. There you go. So we've got the 2, 4, 6, 8. He's writing down the multiples of 2 first before he multiplies them each by 10. And as we know, when you multiply them each by 10, you're adding the 0 because you're moving the place value of each of the numbers. So he's gone all the way to 260 there. As you'll see if he adds those zeros, he'll just go all the way up to 260. You won't need those because they need to be less than 180, but he's just probably showing you how that could work. We're going to the 30 times tables now. He's going to go 6D. Oh, he hasn't added the 0 there. Oh no, he's going to go in the 3 times tables first and then add the zeros like he's been doing. Very effective method actually. Very good method actually. He's going up to 330. I doubt we'll be going that far, judging by the criteria that I need to get this question right. Okay, so the hard work's done. Well, not the hard work. Well, the easy work's done. The effective work's done because we have all of the multiples that we need. And now all we need to do is identify what are the common multiples of these two numbers, taking into account our two variables, which is that it needs to be greater than 100 and needs to be less than 180. Now I see a common multiple there. He's just circling it now. 60. But that's not greater than 100. So I think, Mr. Saul, you need to get rid of that one. 120, yep. Common multiples, as you can see. I see a 180 there. I see 180. Oh, that's an interesting one. That's a clever one. This is a clever question because we're going to get to an interesting debate into an interesting debate about this. Wish you could have heard it. So he's circled all of the common multiples. I think that's clever. Just make sure you get all of them. And then you go on to the next one, which would be what is greater than 100 and what is less than 180? Well, 60 is less than 180, so that's not going to be the case. We do not want to have 60 as our common multiple of 20 and 30 that is greater than 100. So there you go. He's going to cancel that out. What about 120? Is 120 greater than 100? Yes. Tick. Less than 180? Yes. So 120 is perfect. That is going to be fantastic. That is definitely a common multiple of 20 and 30 that is greater than 100 and less than 180. 180 is an interesting one, and he's just cancelled it out. So clearly, 180. And I've seen Mr. Sewell and I both said that we've seen children actually count 180 because they can see the 180 there. But 180 is not less than 180. 179 is less than 180, but 180 is not. And the criteria says it needs to be less than 180. So therefore, 180 can't count. Of course, 240 can't count. And as he's written in the box there, 120 is his final answer. It is the only number that fits all of the criteria that was in that question. And that question's got a lot of words in it, a lot of things a lot of vocabulary that you need to know. But if you break it down and you do the simple steps that are provided here, you'll be absolutely